Welcome to the next session. We start the session with the question number 25, classroom workbook. 25. For the function f of z equal to 1 divided by 2 minus z into z plus 2. For the function f of z equal to 1 by 2 minus z into z plus 2, comma, the residue at z equal to 2. Residue value at z equal to 2 is blank question. Now here you can see what is the power of 2 minus z? It is 1. So therefore 2 is a pole of order 1. 2 is a pole of order 1. Therefore to get the residue, apply case 1. Residue of f of z at the pole 2 is given by limit z tends to 2 z minus 2 into f of z. I have applied case 1 to get the residue. So this is nothing but limit z tends to 2 z minus 2 into this 1 by f of this f of z is 1 by 2 minus z into z plus 2. So this and this will be cancelled, but minus 1 will come extra. So therefore this is limit z tends to 2 minus 1 by z plus 2. Now replace z by 2, we get minus 1 divided by 4. Write this calculation. The residue of the function f of z equal to z cube divided by f of z equal to z cube divided by z minus 1 whole power 4 into z minus 2 into z minus 3 at z equal to 3. At z equal to 3. Options are given. It is a question given to electrical people in 2017 in IES, Indian Engineering Service. So we need to find residue at 3. Here you can see 3 is a pole of order 1. 3 is a pole of order 1. Therefore, residue of this function at the pole 3 is given by limit z tends to 3 z minus 3 into f of z. Therefore, this limit will be equal to limit z tends to 3 z minus 3 into f of z is 1 divided by z minus 1 whole power 4 into z minus 2 into z minus 3. This z minus 3 will get cancelled. Therefore, replace z by 3. You will get 3 minus 1 whole power 4 into 3 minus 2. So therefore, this is 1 by 16. Oh, we forgot to write z cube at this place. So f of z is z cube. So therefore this becomes this is 2 cube. So therefore this is not 2, this is 3. 3 cube divided by this. Therefore this is 27 by 16. I forgot to write z cube. Make this note. So just z cube by. So 3 cube divided by 3 minus 1 whole power 4 into 3 minus 2. 27 by 16. So option D is right answer. To question number 27. Let f of z equal to 1 by 1 minus z square. F of z equal to 1 by 1 minus z square. The coefficient of 1 by z minus 1 in the Lorentz series expansion of f of z about z equal to 1 is. So the coefficient of 1 by z minus 1 in the Lorentz series expansion of f of z about z equal to 1. That means simply they ask you residue of this function at z equal to 1. But I must know whether 1 is a pole of order 1 or pole of order greater than 1. Now when you factorize this, this will be 1 by 1 minus z into 1 plus z. So here 1 minus z whole power is 1. Therefore 1 is a pole of order 1. 1 is a pole of order 1. Therefore, the residue of the function f of z at the pole 1 is limit z tends to 1, z minus 1 into f of z by case 1. So, therefore, this is limit z tends to 1, z minus 1 into this f of z is 1 by 1 minus z into 1 plus z. So, this and this will be cancelled, but 1 minus 1 will come extra. So, therefore, this is minus 1 divided by 2. So, option B is right answer for question number 27. Note this. The residue of sin z by z power 8 at z equal to 0. The residue of sin z by z power 8 at z equal to 0 is. So here we have a series expansion of sin z. Take this function as f of z. Now I can go for series expansion. So this is 1 by z power 8 into sin z series expansion z minus z cube by 3 factorial plus z power 5 by 5 factorial minus z power 7 by 7 factorial plus z power 9 by 9 factorial minus and so on. What I am doing is I am approaching definition of residue. So what is the definition of residue? The coefficient of 1 by z minus z naught in the Lorentz series expansion of f of z. Here we need to find residue of this function when z is 0. So since sin z has a series expansion, write this. Now this is 1 by z power 7 minus 1 by 3 factorial into z power 5 plus 1 by 3 factorial into 5 1 by 3 factorial this is 1 by 5 factorial into this is z cube minus 1 by 7 factorial into z plus z by 9 factorial minus and so on. Now when you look at this, here the coefficient of 1 by z minus 0 equal to this minus 1 by 7 factorial. So basically this is nothing but residue of f of z at the pole 0 by definition. So the coefficient of 1 by z minus z naught, here z naught is 0. So what it is? Minus 1 by 7 factorial. That is nothing but residue of f of z at 0. So the required residue is minus 1 by 7 factorial. It is option number B. Or you can do by case 2. You can do by case 2. Here f of z is in the form g of z by z minus z naught whole power m. Therefore, we need to find residue, but here m is there, so differentiate this with respect to z, m minus 1 times. So, g power m minus 1 of z naught. But here power is 8. So, here what is g of z? G of z is sin z. We need to differentiate sin z with respect to z 7 times because m value is 8. So, what is the first derivative? G dash of z equal to cos z. Second derivative, g double dash of z minus sin z. Third derivative, minus cos z. Fourth derivative, sin z. Fifth derivative, cos z. Sixth derivative, minus sin z. And 7 times derivative is minus cos z. Therefore, what is the residue in this case? The residue is g power 7 of 0 divided by 7 factorial. Now here cos 0 is 1, minus 1. So therefore this is minus 1 divided by 7 factorial. So this we have done by using case 2 of residue, and this is by definition. See that magic with definition. When you are finding residues of complex valued functions, if you know series expansion of such functions very easily, go through series expansions and apply the definition. Okay. Number 29, very interesting question. Let f of z be an analytic function with a simple pole at z equal to 1 and a double pole at z equal to 2. Simple pole. Simple pole means pole of order 1. So 1 is a pole of order 1, 2 is a double pole, that is 2 is a pole of order 2. Even with the residues are given 1 and minus 2 respectively. So what is my function data? F of z is my function. So 1 is a simple pole. 1 is a simple pole and residue of f of z at 1 equal to 1. 2 is a double pole. That is 2 is a pole of order 2. 2 is a pole of order 2 and its residue is given like this. Residue of f of z at 2 equal to minus 2. F of 0 equal to 0. F of 3 equal to minus 3 by 4. And f is bounded when z tends to infinity. What do you mean by bounded? F is a finite value. So when z tends to infinity, the f takes finite value. Then f of z must be. So very interesting question. F of z is an analytic function having simple pole at 1, double pole at 2. 1 is a pole of order 1 and its residue is given as 1. A residue at 2 is given as minus 2. F of 0 is 0. F of 3 minus 3 by 4. And f is bounded. Bounded means it's a finite value when z tends to infinity. Then what is f of z? Let's go through options. Option A. Actually this is z into z minus 3 minus 1 by 4 plus 1 by z minus 1 minus 2 by z minus 1 plus 1 by z minus 2 whole square. Now let us go through option A. So here 1 is a simple pole. Of course 1 by z minus 1 is there, but 1 by z minus 2 whole square, 2 is a double pole. But what is the coefficient of when you simplify this, basically this expression will be minus 1 by z minus 1. That means what is the coefficient of 1 by z minus 1? Minus 1. But that is nothing but residue. But residue at 1 is 1 only. But in this case, when you simplify option A, the residue at 1 is minus 1. Therefore, this option does not satisfy this condition. Therefore, option A is wrong. Did you understand this? So, when you simplify f of z, particularly these terms 1 by z minus 1 minus 2 by z minus 1, we get minus 1 by z minus 1. So, 1 is a simple pole. It matches with this data. That is very clear. But what is the coefficient of 1 by z minus 1? Minus 1. So that is residue. So residue at 1 is minus 1 in this case, but residue at 1 is given as 1. Therefore, in this case, it does not satisfy this property. So option A is wrong. Now come to B. B is minus 1 by 4 plus 1 by z minus 1 minus 2 by z minus 2 plus 1 by z minus 2 whole square. Now let us see, in this case 1 is a pole of order 1, so 2 is a pole of order 2. Coefficient of 1 by z minus 2 minus 2, coefficient of 1 by z minus 1, 1. So it satisfies this as well as this as well as this, even residues also. So 1 is a simple pole, 2 is a double pole, residue at 1 is 1, residue at 2 is minus 2. I need to check these conditions. F of 0 is 0 and f of 3 equal to minus 3 by 4. So suppose this is f of z. Then replace z by 0. F of 0. This is minus 1 by 4 minus 1. This is plus 1 plus 1 by 4. Yes, we were getting 0. And f of 3. So f of 3. This is minus 1 by 4 plus 1 by 2. This is minus 2 plus 1. So therefore this is 1 by 2 plus 1. This is minus 1 by 4 minus 2 plus 3 by 2. When you simplify this, the LCM is 4. this is minus 1, and this one is this is 8, and this one is 6. So therefore this is minus 9 plus 6, this is minus 3 by 4. Even it fulfills f of 3 equal to minus 3 by 4. That is very clear. And even when you replace z by infinity, it gives a finite value. So therefore it satisfies all given conditions. So B can be right or B need not be right. So hold B. Let's go to C. What is option number C? Option C is 1 by z minus 1 minus 2 by z minus 2 plus 5 by z minus 2 whole square. 1 is a simple pole, 2 is double pole, residue at 1 is 1, residue at 2 is minus 2. So it satisfies almost all properties, but replace z by 0. This is minus 1 plus 1 plus this is 5 by 4. But f of 0 is not equal to 0. So option C is a wrong option because f of 0 is 0 does not satisfied by option C. Now what is option D? This is 15 by 4 plus 1 by z minus 1 plus 2 by z minus 2 minus 7 by z minus 2 whole square. Here 2 is a pole of order 2, but what is the coefficient of 1 by z minus 2? 2. But residue at 2 is minus 2, so it does not satisfy. Residue at 2 is minus 2. So option D is wrong. So A is wrong because of residue. C is wrong because it does not satisfy f of 0 equal to 0. D is wrong because it does not satisfy residue at 2 equal to minus 2. Therefore option B is a right answer. Note these points. The sum of residues of f of z equal to 2z divided by z minus 1 whole square into z minus 2 at its singular points is, options are given, minus 8, minus 4, 0, 4. So function is 2z by z minus 1 whole square into z minus 2. Actually sum of reduce concept is very useful for contour integration. Okay, so keeping that in the mind, they have set the question like this. It was given to electrical IES in 2017, Indian Engineering Service. Now let us handle this. So here 1 is a pole of order 2, 2 is a pole of order 1. 1 is a pole of order 2, 2 is a pole of order 1. So to get the residue at 1, you need to apply case 2. To get the residue at 2, you will apply case 1. Okay. Let me write out this. Here 1 is a pole of order 2. 2 is a pole of order 1. Now let us find the residue. Use a residue of this function at the pole 1. So here f of z can be written as 2z by z minus 2 whole divided by z minus 1 whole square. Now this function I call it as g of z. So this is in the form g of z by z minus z naught whole power m. So what is my g of z? This is 2z by z minus 2. Z naught is 1. M value is 2. So to find the residue of this function at the pole 1, what we need to do is differentiate this with respect to z m minus 1 times. But here m is 2. So differentiate this g of z, 2z by z minus 2 with respect to z 1 time. So here what is my g of z? 2z by z minus 2. Actually I want this g dash of z. You can apply coefficient rule, or in simple way this can be written as 2 into z minus 2 plus 2 divided by z minus 2. So therefore this is 2 plus 4 divided by z minus 2. Therefore the derivative of this function is minus 4 by z minus 2 whole square. Therefore the residue of f of z at 1 is given by g power 1 of this is 1 divided by 1 factorial. So here g dash of 1, replace z by 1. So here g dash of 1 equal to minus 4. So minus 4 by 1, it is minus 4. So residue at 1 is minus 4. Now let us calculate residue at 2. Here 2 is a pole of order 2, pole of order 1, you can apply case 1. So residue of f of z at 2 is limit z tends to 2, z minus 2 into f of z. So therefore limit z tends to 2, z minus 2 into, what is my f of z? F of z is 2z by z minus 2 whole square, 2z by z minus 1 whole square into z minus 2. Z minus 2 gets cancelled. This will be 4. So one residue is minus 4 and second residue is plus 4. So sum of residues equal to 0. Sum of residues is 0. So option C is right answer. Given that f of z equal to 9 by z minus 1 into z plus 2 whole square. 9 by z minus 1 into z plus 2 whole square. Which of the following is one of the residues of above function? So options are given like this. Minus 1, B 9 by 10, C 2 and D is 9. D is given as 9. So let us try to find. Here the point is, they did not mention at what point we need to find residue. So that is our job to find the residue. First find the residue at 1. 1 is a pole of order 1. 1 is a pole of order 1. Simple pole. Minus 2 is a pole of order 2. So first let us find pole or residue at 1. If that answer is available in the options, you can opt it. Otherwise, you need to find residue at minus 2. So let us find residue of f of z at the pole 1. This is given by limit z tends to 1, z minus 1 into f of z. F of z is 9 by z minus 1 into z plus 2 whole square. This and this will be cancelled. So 9 by 9, it is 1. But 1 is not there in options. So therefore, they did not ask you residue at 1. So indirectly, they have asked you residue at minus 2. But it is a pole of order 2. So you need to apply case 2. So to get case 2, f of z must be written in the form g of z by z minus z naught whole power m. So therefore, this is 9 by z minus 1 divided by z plus 2 whole square. Now this is my z of z. Here power is 2, so differentiate this with respect to z one time. Z of z is 9 by z minus 1. G dash of z is minus 9 by z minus 1 whole square. Now what is the point? Minus 2. So g dash of minus 2. Replace z by minus 2, you will get minus 1. So therefore the residue of f of z at the second pole minus 2 equal to g dash of minus 2 divided by 1 factorial. This is by applying case 2 to get residue. But g dash of minus 2 is minus 1. So therefore minus 1 is one of the residue. So indirectly they have asked us to find the residue at the pole minus 2. But if 1 is available in the options, you can opt it. But it is not there. So we need to find residue of this function at the second pole minus 2. We move to question number 32. For the function f of z equal to 16z divided by z plus 3 into z minus 1 whole square, comma the residue at the pole z equal to 1. So here the question was very clear. We need to find the residue of this function at the pole z equal to 1. But 1 is a pole of order 2. So here 1 is a pole of order 2. So that means you need to apply case 2. So here f of z, I can write it as 16z by z plus 3 divided by z minus 1 whole square. Now this is in the form g of z by z minus z naught whole power m. Here what is z of z? 16z by z plus 3. But here power is 2, so differentiate this with respect to z one time. This we can write it as 16 into z plus 3 minus 3 divided by z plus 3. Therefore, this g of z equal to 16 minus 48 divided by z plus 3. Therefore, the derivative is g dash of z equal to 48 divided by z plus 3 whole square. So at 1 you need to find. Therefore, g dash of 1 equal to 48 by 1 plus 3 whole square. So this is 48 by 4 square 16. This is 3. Therefore, the residue of the function f of z at the pole 1 is g dash of 1 divided by 1 factorial. So this is 3. So the answer is 3. So we have applied case 2. We are getting directly residue as 3.